Okay, welcome everyone back from lunch. In the afternoon, we're going to learn about a database technology, and we're going to encounter it using Python. And this technology plays a large role in the materials project and how we manage our workflows for calculations and how we manage our data and process it and how we present it and how ultimately you can query it in very powerful ways. And it's certainly something you can take home with you and use to manage your own data if you're so inclined. Yeah, let's get started. So if people have their notebook up, make sure to go to the MongoDB primer folder and open up this Unit 1 notes file. For a lot of the other stuff, for most of the other stuff, I'm going to be working in a blank notebook, and I want you to as well. But this one, some of the stuff is a little tricky and it involves some initialization. So mostly we're going to sort of walk through it together and execute cells. So first, just a little bit about MongoDB. For those familiar with databases or who've heard of or worked with SQL, which is a relation-oriented database, MongoDB is a little bit different. It's what's known as a document-oriented database, and it works particularly well with data where a lot of times the way you're accessing it and working with it is as something that's sort of document-like. If you imagine like a paper document, it has some hierarchical structure that you often want to take with you. A document, will have a title, it'll have sections, figures, paragraphs, sentences. There's a lot of hierarchy with all the data, and you are often interested in sort of querying at that document level, as opposed to all the different relations and having different tables holding, your sections that relate to your paragraphs and joining everything together. And that's a lot of the data style that we deal with in the materials project. You'll see examples of this tomorrow. In particular, we'll represent a crystal structure as sort of something hierarchical that has things like a lattice and sites that annotate different elements. So we found that the document model is a really expressive way of storing and working with our data. So that's why we're focusing on MongoDB rather than something like SQL. Throughout this lesson this afternoon, we're going to be working with the Nobel Prize data set that's officially released by the Nobel Foundation. I'm just editing my markdown cell real quick. So let's go over some of the ways that we represent this data. And we already know a lot about this just from having learned about the basic data structures in the last lesson, things like dictionaries and lists and basic ways of hierarchically organizing data. So there's this notation called JavaScript object notation, which is the way that a lot of data are interchanged on the web. If you'll deal with an API on a website, a lot of the basic way in which things are transported have to do with this. And so it's good to sort of know this notation and how it maps onto Python. So for example, in JSON, there are things called objects, represented with curly braces, and they'll have this string key and some value, or a collection of those. There will also be something called an array, which is denoted with square brackets and has a value or a number of values. Then there are, of course, the values themselves, which can be one of a number of primitive types. Something that's a string, like something in quotes, a number, from an integer to a floating point number, these constants that designate true, false, or nothing, I don't know, but also objects and arrays themselves can be values. So how does this relate to what we just learned with Python? Well, what JSON calls an object, Python just calls a dictionary. And in Python, your keys can be anything. They can be a tuple. They can be anything that's immutable, that you can't change. With JSON, it just has to be a string, just a name. Arrays in JSON are just lists in Python parlance, just an ordered sequence of values. And finally, values, we learned about the type function to get the type of something. So here are some examples of Python types that correspond to JSON types. The string, integer, float, true, false, none, dict, and list. So now I want to present a sort of cartoonish, but good for our purpose, mental model of how MongoDB works and how it's structured. It's not exactly how it works, but I think it's useful to think of it this way. In MongoDB, you might think of a database as an object, where each of its keys are actually collection names, and the values are collections. So it's just a set of collections. In addition, documents themselves are actually structured as dictionaries, as we'll see. And because you can have substructure, as we saw, with the space group example, where it had a sub-dictionary. Similarly, in MongoDB, you have this idea of subdocuments. In MongoDB, you can have a number of collections. So you might refer to each collection by name. That's the database. And each collection you can think of as a list of documents. You're not necessarily it's not going to be in a set order necessarily, but it's a collection of documents that you can iterate through. And similarly with values. It's actually the case that as opposed to JSON, which only has very simple types, the so-called binary SON format of MongoDB allows you to embed certain types that are native to Python and which you might want to work with at a higher level. We won't get much into, but things like datetime objects or regular expressions to denote a pattern. You can represent these natively in MongoDB, just like you can in Python. Okay, so what we're going to do now is we're actually going to connect to our database. And you all have MongoDB running in your containers. So that's great. And we're actually going to fetch from the Nobel Prize API at api.nobelprize.org and actually fetch all of our data and insert it into the collection. Because web APIs usually use JSON format anyway, it's actually quite straightforward to start a Mongo database right away. So I'm going to execute these cells one by one, and I'd like you to do so as well, because we need to make sure that you have the database on your system. So when I go in here, I am going to hit Shift-Enter to execute the cell, so I can see that that cell's been executed. I'm importing this request library, which is a third-party library. It's not built into Python, but it's very popular, and it's used to get things from the web. I'm also going to, from PyMongo, which is the Python MongoDB driver, officially supported by MongoDB, I'm going to import this thing called Mongo Client, so we can connect to a database. In this case, I don't have to pass anything to Mongo Client. I don't have to pass some server name, some port number, some username and password, because we're actually just connecting to the default one that's on your system. And I'm actually going to take this client and I'm going to access, as if it were a dictionary, this Nobel thing, whatever that points to. And I've actually just created a database on the fly. Mongo is very dynamic in that way. You don't have to preset schema or name your collections. You can sort of do that a little bit later if you want to. So you can get started really right away and then bake in your validation later. This is also very helpful. So I've created a database called DB on the client. Now we went over for loops. So for collection name in Hobby's collection names, prizes, and laureates, I'm actually going to get the singular of it because that's what the Nobel Prize API recommends. So we did this slicing. So here singular is just going to be prize or laureate. And I'm going to use the request library to get this thing over here. And this is a string method we hadn't covered before. But I'm essentially going to take that singular and insert it where these curly braces are. So I'm accessing the URL /v1/prizes and then /v1/laureates. I'm going to get the JSON response, and inside that is a dictionary. The collection name will have my data, my documents. And then I'm going to make sure that I'm accessing my Nobel database with that collection name, prizes. I'm going to make sure to drop that database if it exists already. And then I'm going to insert many documents into that database. So hopefully it's as easy for you as it was for me. So we just downloaded a couple of collections of all Nobel laureates. Okay. Now just a note, you can access databases and collections as attributes in addition to treating as dictionaries. So Mongo allows this. So rather than having to type client and use this dictionary interface, you can also just say client.nobel. And in order to access the prizes collection within the Nobel database on the connected client, you can use this notation. You can also use this notation. Here I'm using the Python assert keyword to assert that this statement is true, and it'll throw an exception if it's not true. So this is a nice way of kind of doing defensive programming and making sure that your assertions make sense. The last thing I want to go over before we get right into an exercise is a collection method to count the documents. So I've already sort of wrapped this up, but I'll just sort of I'm going to sort of hit this, and there are various keyboard shortcuts. I'm going to type A in order to insert an empty cell above and hit enter to go into it. And I'm just going to go ahead and try and execute this line to count the documents. And it turns out this method requires one positional argument, which is a filter. Which means of these documents, do I want to filter by anything? Do I want to filter by, when the Nobel Prize was awarded or their first name or any sort of thing? And I'm indicating that I want no filter by having this all-accepting empty dictionary. So here I sort of demonstrate that by using this try except block, which is a way to catch errors that you think might happen in Python, and just printing out that error, but then I actually want to print out the actual value. So we have 590 prize documents. Okay, so now that we're there, we have a database, and so now we can do other things with it. Go ahead and put up a red sticky note, I guess, if you weren't able to run that. We'll make sure everyone gets started. Okay, great. Okay, at this point, I'm going to go back to my MongoDB primer folder, that tab, and I'd like you to do this as well. Go to Unit 101 Exercises. And here's our first exercise. Count of prizes versus laureates. Which of the following statements is true? The number of prizes and laureates are equal. That is the documents in those collections. Prizes outnumber laureates by less than a factor of 2, outnumber by greater than a factor of 2, etc. So what I'd like now, I'm going to go to my polls. I'm going to activate this poll. I'm not going to show the results. But everyone just go ahead and give your answer. And I'm not showing the results because I don't want people to say, oh, that must be the answer, because already 2 people submitted that. And I'm doing this because, and I'm going to try to do this with a lot of the exercises, I think there are different reasons for why a different wrong answer would be thought of. And so I want to make sure to address that before we go on. So go ahead and go to pollev.com/mpworkshop, and then enter one of these. I guess you can also, go by text if you want. I'm going to go ahead and look at the responses that we got. Okay, looks like we're actually pretty split. So it's definitely a good idea to go through this and clear up some misconceptions. Okay. So what I want to do here is first I want to go ahead and make sure I have my database available to me. So from PyMongo import Mongo client. Client equals Mongo client. And then db equals client Nobel. Keep this on hand. This is a good way to always refer to that database. Okay, so what I want to do here, let me see if I can hide this. db.prizes.count. I'll try to use that tab complete trick. Doesn't quite work. Count documents. I get 590. And I'll go ahead and try and copy this cell. I'm going to do that by having this highlighted outside and pressing C and then pressing V. Shortcut I like to use. But essentially I just need to get this laureates collection and count that. So we see there are more laureates than there are prizes, and that's because many laureates share prizes. And looks like the laureates outnumber the prizes by less than 2x. So we just used that simple collection method to get the count in each collection, and so we have some basic idea of those counts and their comparison. Okay. Now let's walk through another exercise just to see, what the structure of the database is. Okay. So as I mentioned, our Mongo client object is not actually a dictionary. So we can't call keys to list the names of accessible databases. Keys is a method you can list on dictionaries. Like if we have a dictionary, called H1, helium-2, I can call d.keys in order to get the keys of that dictionary. I can also make sure they're a list and do that. Just something to know about Python. We can list database names by calling list database names on a client instance. And we can list collection names by calling list collection names on a database instance. So here's what I'd like us to do. Save a list called db names, and we have all this skeleton code down here of the names of the databases managed by our connected client. Similarly, save a list called Nobel collection names of the names of the collections managed by the Nobel database. And what I want to know is how many databases are actually managed by our client. I feel like it's at least one, because we definitely have a Nobel database. But I'd like people to see how many databases are managed by the client. And please also go to the poll software and go ahead and put in your answer there. I already see one person has put in more than 3. I do not have a filled out version. Okay, if you have more than 3 and a couple have 2, one has 3, okay, we're getting some differences. This is good. So while people are still working on that, I'm just going to sort of go through this one cell at a time. So first of all, make sure we have our client connected. Here, maybe this was a mistake. I think I'm going to just copy and cut this out and make a new cell above it so that I can execute just it. So I'm going to say list database names. Okay, so it looks like I have more than 3. I have 4. So what's happening here? Well, MongoDB actually uses databases itself in order to kind of manage things. So there is an admin database that might store information about how you might connect to it if it's password protected. There's some sort of configuration stuff, local. We won't go into why that's happening, but just in case you're confused, these things are there. Probably a good idea to not name your databases those names. Just a little bit about something going under the hood. Let's go ahead and do this now. Client.nobel, we want to access the Nobel database, and let's list the collection names. Okay, we have those 2 collections, laureates and prizes. Great. Okay, one final exercise I want to go through just to get a sense of what's going on in each of these documents. So what you want to do is you want to use the collections find_1 method to return a document. This method takes an optional filter argument, just like count documents. Passing an empty filter in this case is the same as passing no filter. You can actually pass no filter, as I sort of template here. In Python, the return document takes the form of a dictionary. It's technically a document, but it translates directly to a dictionary. And in Mongo terminology, the keys of this dictionary are what are termed the root level fields of a document. So if I go through this, I'll connect my client. I don't actually have to do this every time because we're in the notebook, so we already have the client, but I just sort of wanted these pieces of code to be very self-contained. Connecting to the Nobel database, calling it DB, and I'll retrieve a prize and a laureate document. So each laureate document has a prizes field. Let's go ahead and just look at this real quick. Laureate, L-A-U-R-E-A-T-E. Okay, so there are a bunch of fields right here. This underscore ID with this strange object, this is something that MongoDB uses so that you can uniquely identify the document. It's actually pretty important when you're dealing with huge data sets that have to fit on multiple machines and they're generated independently, because it guarantees that this is quite random and depends on your system and the time, so you can easily merge collections. So you don't have to have an auto incrementer for documents, if people are familiar with that sort of thing. But so this is how the Nobel Prize API decided to format its data. There's an ID, there's this field first name, Gesundheit. All these fields in here. And there's this field prizes, which is a hierarchical structure. It's actually a list of all of the prizes that laureate has won. In this case, there's actually, it's sort of hard to see, and match this outer paren, but there is one prize. This laureate has won one prize. And let's sort of go over that a little bit. Well, here's a section of actually one laureate who's won two prizes. And I sort of allied some fields. The prizes has more than year and category, but you can kind of get the idea that you can have this nested structure to represent a laureate. Okay, so I want to get a sense of what's going on in these documents using a couple of tools we've learned from the last section that are going to be very important for MongoDB. So this collection is something you can iterate over, just like you can iterate over a list. However, a collection is not a list, so we can't write, for example, for document in collection to iterate over documents. Instead, you call this collection method called find, which also can take a filter, to produce an iterable that's called a cursor. Sort of like if you have a document and you have your cursor, the blinking thing in the middle of it, that's sort of where you are, and you can move the cursor. It's sort of something that tells you where you are in that iterator. And you use this to iterate over documents. So here's what I'd like you to do. I'd like you to save a list of the fields present in each document to this variable prize fields and laureate fields, respectively. Recall that the .keys method of a dictionary returns a view of its keys, and you're going to need to pass this to Python's list constructor to obtain a list. Then what I want you to do is use the find method to iterate over laureate documents, sum the total number of laureate prizes. So we're actually using this comprehension in here in order to do this. And how we're going to do this, the number of laureate prize shares, we're going to estimate this as the length of the value of this field, prizes, for a laureate document. And so I want you to complete this to say, not how many laureate documents there are, but how many laureate prizes there are, how many elements there are in all of the prize fields of all laureates. So the total number of prize shares. It's going to be one of these things. And go ahead and submit that also to the survey. I'll put that up right now. Also, please remember to, if you're done, go ahead and put up your green sticky. But in general, once we've moved on to another thing, remember to take it down so that our helpers can see if maybe you're in trouble but haven't put up the red sticky yet, that sort of thing. Okay, great. I see we've gotten a bunch of responses. mostly split between 941 and 935. So let's see what's going on here. I'm going to go ahead and use these documents that I made up here, prize and laureate. So I'll say prize.keys list, laureate.keys list. And what I want to do, the total number of laureate prizes. So I want to have a cursor on the laureates collection. So laureates.find. For each laureate document, I want to access the value of the prizes field, and I want to get the length of that value. And we kind of didn't go over this type of comprehension because I'm not making it a list or a set. In fact, it's something that's also an iterator, so it just sort of gets fed to some, and some reads it as if it were a list. So it works the same way. And I get that the value is 941. So the issue with 935, I don't have my notes here actually for that, but it may be that someone was using the prizes collection instead or something like that. Let's see what happens if I do that. Well, there's a key error. Apologies about that, but I hope this explication was illuminating to people who got 935 and they understand how this is obtained. Okay. Actually, I can stay on the page. So that's unit 1. Now, I'm going to go into unit 2. So I'm going to click on unit 2 notes. And in this case, what I'm going to do is actually, I might delete things in the notebook so that I can sort of type them out live. But they're there for you in case you want to execute things and get behind a bit, so that we make sure that we're all sort of on the same page. So now we've been able to iterate over a whole collection using find, right? But if we have a huge collection, we don't necessarily want to pull it all down. We're actually maybe interested if something of interest is in that collection. Like, you know, there's a material that we're interested in that has certain properties. Or in this case, there's a Nobel laureate or a prize that seems interesting, or we want to do some statistics on certain things. So here's an example laureates document. It's got all these keys. It seems to be a lot of biographical stuff: born city, born country, died city as applicable, first name, gender, list of prizes, with affiliations for the prize, maybe a category, motivation, a share of the prize. So here's our standard setup. And what I'm doing right here, I'll just sort of write this out so I make sure that we get it. I can count documents, as mentioned before, by providing a filter. So I'll just count documents. And how do we structure a document? Well, I'm going to give it a dictionary, and I'm actually going to use auto indentation in order to do this, so things look a little bit better. I'm going to give it a key. I'm going to say born. I'll use double quotes. There's actually there's no difference, just in case you want to nest things within another. I'll try to use double quotes as often as possible. So I maybe want to find something where born is 1845, 0327, and let's just say surname R-O-N-T-G-E-N. So there's one. So this is how I specified a filter. Now this is actually the document for someone who won the prize for X-rays, Wilhelm Röntgen. And actually, filtering in MongoDB reminds me a lot of what X-rays are. So this is an image of one of the first X-rays. I think it's the first X-ray. And so I view a Mongo filter as sort of like an X-ray, where what are the relevant parts of this? Like this, you might be finding an image that's of a human hand. But you might have sort of salient aspects of it that are important, that you want to make sure are there. Maybe you care that there's skin or not, but you care that it's a hand that has bones. You care that there's some ring of some sort on this thing. It's something that you can overlay over something with more data as sort of a structure. Let me give you another example. You might have a bunch of documents. Jimmy, Amelia, Charlie, Wally, and you'd supply, Levi, this pair of pants as a filter over these documents. I would argue, depending on your interpretation, it might actually match for Jimmy, Amelia, and Charlie because they all have pants. It sort of fits that structure, but Wally would be out. So Mongo filters are this sort of declarative way of saying, like, I know you have this big dictionary, and I sort of want to specify this substructure and tell me things that match that. It's a little more nuanced than that, but that's sort of how I like to think of it. As we've also seen, you can compose filters. So in the spirit of typing, I'm gonna type all this stuff. So I might have, okay, DB laureates, might count documents that have this field, gender female, get 51. Now I want to sort of compose this with another filter. In some languages you might say, okay, this condition and this other condition. With MongoDB, because it's a dictionary, in order to compose these things, you simply add another key value pair in the dictionary. That's how you sort of merge together filters. You might have died country, France, and let's do another one. Born city, Warsaw. So this is actually Marie Curie. And actually one of the themes that we'll be doing, trying to solve and tease out data about for our Nobel Prize collection is what proportion of Nobel Prizes were awarded to immigrants. That is, people who sort of won their prize not in the country they were born. Marie Curie has an interesting story. Her home country of Poland was under Russian rule at the time. When she moved to France, and perhaps the first politically motivated element naming, she named an element she discovered, polonium, after her home country that she missed. Okay, so let's go over query operators. I mentioned that with the pants example, we can sort of fit something on that's sort of the same structure. But you kind of need to be able to do more than that. Like, how do you say if something's in a certain list or greater than or less than that? So query operators are Mongo's answer to that, to sort of still maintain the structure of a document, but bake in some querying. So I like to view query operators as sort of like web forms. This is sort of a structure that you have. You sort of have like the name up here, and you sort of can say, okay, it takes in a certain value. And then you have this other field, country of residence, and you kind of say, okay, that field has to take in one of these options here. In this case, France and a few other ones. And you might have this other field called value in a range, which might be less than some value or at some certain value. So this sort of form field gives you an idea of, it retains the structure, but gives you a sense of how you might specify something. So I'm going to go over this interactively. So I might want to count documents where the value of died country, I don't want to say is USA. I want to say it can be a bunch of things. So, okay, I'll sort of go into structure here, and rather than say USA, it's going to be a dictionary, and I'm going to have this operator using this operator syntax, $. In, and then I'm going to give it this list of France and USA. And that's how you say, I want a count of laureates where the died country is either France or equal to USA. But it still maintains this nested dictionary JSON structure. And so that's how MongoDB does that. Some additional options. I'm going to make sure I'm out here. I'm going to hit C and then V, just so I paste the cell so I can don't do as much typing. What if I want to make sure that where the died country is not France? Well, there's another operator for that. There are operators for a lot of these things. In this case, it's $NE, not equal to. And here I just want one value. Okay. Finally, let's say something where died country is, I'm going to sort of hit enter here so that I can make things a little bit more visually appealing. I'm going to say, I'm going to use the $GT operator, GTE greater than or equal to, Belgium, and less than or equal to the USA. Now, how dare Mongo have this sense that some countries are greater than or less than others, right? That doesn't make any sense. So actually, this is because Mongo is very loose, as there are a lot of other programming languages, about how you make things comparable or not. In this case, it's using string comparison, right? So any country that fits this that has, when it's sorted, greater than BEL. So if Bavaria was considered a country in this data set, then it would be greater than Belgium. Chile, all these things up to or less than or equal to something that is USA. So I'm trying to slip in little things about data quality and validation in here. And this isn't particular to Mongo. This is sort of anything. A lot of times you have to be careful about what types your system supports and what kinds of comparisons are meaningful or not. Okay, and again, we can sort of keep composing however you want. You can have another thing on the outside level, like first name Albert. Things like that. Okay. Let's now get to some exercises about finding things. So up here, I include this convenient, thing for you, so you make sure you can just reference DB and do things with that. Okay, another thing is sort of about data quality and comparison. So the born field in a laureate collection document records the date of birth of that laureate. Born values are in the standard form where you have a 4-digit year, dash, 2-digit month, dash, 2-digit day, also known as ISO 8601 format. An example is 1937-02-01 for February 1st, 1937. This format is convenient for what I mentioned, this lexicographic sort order. It's sort of a generalization of alphabetical. And thus comparison. For example, this query, count documents, filter born, $less than 1900, returns the number of laureates with recorded dates of birth earlier than the year 1900. Because the string 1900 is greater than, even a string of greater length that starts with, 1-8 something. So using the query format above, what is the number of laureates born prior to 1800? What about prior to 1700? There are 3 options here. I'd like you to answer that in the poll. Okay, I think we've got a few in. The result is quite surprising, I would say. What you get is that there are, according to this, there are 38 prior to 1800 and 38 prior to 1700. Now, I don't know about you, but the first Nobel Prize was awarded in 1901, so that's a little weird, right? That's great. No, I was just going to get into that. So it turns out that when a laureate's date of birth is not known, in this API, the born field is recorded as 0000-00-00. Now you can make all sorts of choices when you're encoding your data. Some people might encode the value none, like there's no born date. They might not even have born none. They might just not have the born field there at all. What the Nobel Prize API decided to do is always have a born field, always have a date, and just you should know that 0, it means nothing. So it's very important to validate and clean your data and look at it before you do any analyses, right? This isn't a cooked example. This is the Nobel Prize API. So just wherever you get data from, be careful. Okay, there are a couple of other exercises here, but I want to move on. So there's an exercise about composing filters and about more practice with the $in operator and the .ne not equal, not equal operator. Please do those on your own time. We are instead going to move on to Unit 3. So you can click on Unit 3 Notes. So we're going to talk about arrays, subdocuments, and dot notation. Okay, so we're going to use the find_one method to retrieve one of my favorite laureates. Walter Kohn co-developed an important technique for computational chemistry that many of you may work in. So first I'll sort of do our standard little thing. I typed F without being in a cell. From PyMongo, import Mongo client. And again, feel free to type along. It's good to sort of get the muscle memory in your fingers. But again, if you sort of mess up, these cells are here for you to kind of keep pace. So connect to my Mongo client, set a little alias for my Nobel Prize database. I'm going to say DB laureates, find one. I'm going to use my indented structure so I can see everything really well. I'm going to look for first name Walter and last name Kohn. And I remember this from having looked at an example document. so I know the names of these keys. Okay, so I guess I found one. Usually it prints out. You know what? I think it's surname. That's right. So Walter Cohn, all this stuff. So you see here in the prizes array, he's got one prize, 1998 in chemistry, for his development of the density functional theory. And his affiliation could have multiple affiliations. One affiliation for that prize was with the University of California at Santa Barbara. Now, how do I sort of nest in there if I sort of, want to find that? I kind of can see, first name is Walter, surname Cohn, but how do I kind of go in there? Well, here's how you do that. Use what's called dot notation for MongoDB. So I'll count documents, and I'm going to say prizes. You can look up here. Prizes. And then the next field within there is affiliations. And notice this isn't a dictionary. Prizes is actually an array of dictionaries. But still, this sort of dot allows you to go in whether it's a dictionary or an array of dictionaries. It's sort of the next level and the key at that level. And I'm going to go in one more level and talk about name. So I can get dot name, University of California. And so I actually see that there are 34 laureates whom, for at least one of their prizes, if they have more than one prize, have at least one affiliation. Maybe they were multiply affiliated at the time of that prize. At least one of those affiliations has the name University of California. Another thing I can do is I can look at city. This is for Santa Barbara. But I'm interested, as a Berkeley alum, how many Nobel Prize have affiliations with Berkeley. 19. Go Bears. All right. So,
Stanford 22.
All right. So, we went over some issue with the born field being overridden and having zeros when it's someone's not born. But actually, the Nobel Prize API makes a different decision when it comes to a different thing. So I'm going to find a laureate with a surname of Naipaul. Naipaul, yes. So this is a person who won the 2001 Nobel Prize in Literature, and there's something interesting, which is, certainly this person was born, but there is actually no born country field. So the Nobel Prize Committee doesn't really know where he was born, certainly died in the UK. So how do we deal with that in MongoDB? Well, there's this other operator. We can count the number of documents that pertain to it, or we can look at a field and specify, sort of wrap around it, that dollar exists. Does this field exist or not? And we can say false. That's how MongoDB will check for the existence of a field, as distinct from whether a field has the value null or none, or quadruple zero as it may be. So there are 32 laureates that just don't have a born country field. So we can also do this by reaching into array fields. So if we look at a count of all the laureate documents, so as we've seen before, we have 934. And we can see, for example, how many of them have a prizes array. I sure hope the answer is 934, because otherwise, why are they in the laureates collection? And we're in luck. So here's another interesting thing I want to introduce, is we use dot notation to sort of go into a named field, whether it was in a nested dictionary or not. But actually, we can have it go into an array. You can think of an array, at least with JSON in this case, as being a dictionary where the keys are the indices. You know, what's the value at index at key 0 or at 1, as being the 0th or first. So here we can sort of query, okay, does there exist a 0th prize? And of course, all of them have at least one prize. But we can also ask, is there a prize existing at sort of the second index? That is, how many documents have at least 2 elements in the prizes array? The answer is 6. I show 4 of them here because the other 2 are actually quite special. And they're going to lead into our next lesson. Okay, so I want to go now to Unit 3 exercises. And we're just going to have time for this first little checkup. There are other tools to help you do more with criteria, and I might kind of just do this down there for you, but I want to get a sense of this. So we saw from his laureate document that Walter Cohn's country of birth was Austria, and that his prize affiliation country was USA. If we want to count the number of laureates born in Austria with a prize affiliation country that is not also Austria, what MongoDB concepts tools should we use? Dot notation and the $NE not equal operator, bracket notation and the $exists operator, dot notation and the $exists operator, or dot notation and the $in operator. This one I'd like someone to shout out if they think they see what are the relevant tools that people want to use for this. Anyone? Do we want to use bracket notation? No. I didn't say what bracket notation was. It's not a thing. But dot notation is a thing. And we do want to use that because we want to sort of go, prize dot affiliation country. It's a nested field. The other key here is, not also Austria. So we're going to want some field designation. I think we're actually probably going to say prize.affiliation.country in the dictionary with the key $NE and the value Austria. So that's sort of what we're going to use there. Okay. Being mindful of time here and the things I want to make sure to get through, I do want to just walk through this sort of special laureate thing. So I want to filter for laureates with at least 3 prizes. Right, so what I'm going to do here is I'm going to say prizes.012, so the third array, and I want to make sure that that exists. And because this is a dictionary, we can sort of compose things like this. We can have one part of our program composing the criteria and holding it as data. So the code is data, and then passing it over here. So I've got nothing, I think, because I didn't run my standard block where I start stuff. And let's get one down here. So what's happening here? It's the International Committee of the Red Cross. It's won several prizes. I don't know if you knew that organizations could win Nobel Prizes. They certainly do. Several scientists up on the hill where I work shared part of the Nobel Peace Prize some years ago for being part of the Intergovernmental Panel on Climate Change. And again, the Red Cross has also won a number of prizes. Okay. We just did this. So we're in Unit 4 right now, and we're going to work with distinct values and sets. So we learned a little bit about how to deal with sets in Python. And it's often very useful for doing basic data analysis and cataloging of data. So we'll do a little bit of that here. So we just saw that I'm executing these two cells up here, that there's this International Committee of the Red Cross. When was it born? Does it make sense to say when it was born? Maybe when the organization was founded. The Nobel Committee decided that we're just going to call it 0. What's the gender of this laureate? The API decided we're going to call it ORG. So we're going to say it's an organization, so that's its gender, because we want that schema to be, that's what we decided. Okay, so now we're going to look at this convenience method, .distinct. What happens when I say something like db.laureates? We already learned about find for getting a cursor, find one for getting one, list collection names. No, that's a database method. Count documents. So distinct is another convenience method. And it returns a list of all of the distinct values of that field across the collection. Quite handy. Unfortunately, we don't have time to cover custom aggregations in this lesson today, but the .aggregate method of a collection is quite powerful. It uses syntax similar to find syntax, and you can do a lot of powerful analyses across collections and essentially have Mongo do it for you. Not have to pull all of the data to your system if there's a lot of data and do all the analyses there. Because it's going across the whole collection, it might be a large collection. It's more efficient if there's something called a collection index on the field. And we will learn how to create an index later in this lesson, because it has quite an impact on performance. And if you create your own databases or you notice something slow, that's sort of a big place to look. There's that story of the consultant that was brought in and looked at a system and just replaced a single screw, and then had a huge bill for it. And he was asked to itemize all of that, because what is this? You only spent 15 minutes. So he had it big itemized and said, okay, the cost of the screw is 15 cents. Knowing where to put the screw, that was the rest of it. So indexes are one of these things where you could go in and have all these problems, and it's like, well, maybe you should add an index to it, and then you just do it. It's a line, and it magically fixes things. So one thing to keep in mind about databases, indexes. We'll go over that. However, no index is needed here. This collection is, I think, like a 1/4 megabyte fits in memory, has 1,000 documents. You don't have to fetch from disk or the network. So, it's very quick. So what do I have here? We have this document where we're sort of finding that this thing exists. And this is just to refresh the schema, because it's not defined. Any document can sort of have whatever it wants in it. It's just sort of by convention that you should have a schema that is roughly the same across documents, because then it's easier to index things and to search across things. So we just notice, okay, prizes.category, that's sort of where the prize categories are. So we can similarly use dot notation in this method as well and find the distinct prize categories. Okay, so before we move on, let's make sure we understand what's going on here. So let's go to Unit 4, Exercises, that notebook. I'm going to execute this to make sure I have a handle on local database. And these lines are a little long, but if you kind of have it at a normal size in your screen, hopefully you kind of see that there are 3 distinct lines as these options. And I want to know what expression asserts that the distinct Nobel Prize categories cataloged by the prizes collection are the same as those cataloged by the laureates collection. So remember to explore sample documents by saying, for example, DB prizes find one and laureates find one, so you know that which field and which dotted path corresponds to which value that you're interested in. That should be the same across both documents. Okay, so there are a couple of tripping points here. So let's go with the second one. So the second one actually is not correct, because prizes do not have a laureates field that has a sub-field of category. Prizes actually just have a root level category field, not embedded within laureates. So it's going to be one of these two. So the difference between these two is this one sort of gets the distinct back, and this one wraps it in the set operator. Now I'll give you credit if it's number 1 and they happen to be equal, but it's a little dependent on the order in which the aggregation happens to traverse, because you could get lists that are equivalent and that they both contain n members and the same n members, but when you use equal in Python, that means, okay, the first element is equal to the first element, the second equal to the second. Whereas if you use the set abstraction, you have this notion of set equality, where it sort of doesn't matter the order, it's just sort of n things. And so 3 would be the correct thing. So even though distinct gives you back, something, the number of distinct ones, that the format it gives you that is as a list. So you have to be careful about things like that. Okay. There are a couple of other exercises, but again, we're going to go on, and feel free to go through those at a later time. Unit 5, notes. And just so you know where we're headed, I intend this to take about 15 minutes, and then at 2:30 ish, we'll have a coffee break for 15 minutes, and then come back for the second half of the day. Okay, so what I'm going to do now start with this. And we're going to talk about composing a couple of ideas. So we've had this idea of filters and also this idea of distinct values, right? So now we're going to bring them together. Okay. Awards into prize shares. So if I look at the laureates collection, wow. Okay. Laureates, find one. I'm going to find laureates with very high prize shares. So I'm going to say prizes.share is 4. And what do I mean by this? So we're looking at this. This is Pierre Curie, and he won the prize in 1903 in physics in recognition for radiation phenomena. So he won this with his wife Marie and also with Henri Becquerel. So they were sharing, and I guess his share was a quarter share, whereas one of them had a half share, which is denoted by 2. So again, this is a schema issue, right? This could be represented as share 0.25 as a number. It could be represented as the string 1/4. It was chosen to be represented as the string 4 when it's a quarter share. So one thing we can do now, I'm going to double click here to kind of collapse this down and copy and paste. Actually, I'll go right into here. So I want to figure out what are the high share prize categories. So this is one where it was a prize in physics. I kind of want to find out what are the prize categories that have this kind of high level of sharing. So how might I build that up? I might say, okay, well, what are the distinct prize categories that laureates can have shares in? Here they all are. Next, I'm interested in, well, I guess one thing I could do is I could take this and kind of find all laureates with this prize share, high prize share of 4, and I guess iterate over them, collect them into a list. This is going to be huge. And try and pick out things, right? But I can do one better than that. What I can actually do is I can say db.laureates.distinct, and I want the distinct categories given a pre-filter. So I'm only interested in laureates that satisfy this filter, and I want you to give me the distinct categories therein. So I guess I forgot. Ah, very nice, very nice. I'll do you one better. I will go into the prizes collection and look for distinct categories where the laureates share is 4. And I see that physics, chemistry, and medicine all have prizes that have had quarter shares involved, whereas peace, literature, and economics have not been split as finely. Okay, the last thing I want to look at for this lesson before getting on to an exercise is prize categories with multi-winners, so people who've won more than one Nobel Prize. So let's apply what we just learned to that. So what might I want to do? Laureates. Let's count documents. So multi-winner would be more than one prize. So we want to look into the prizes array and see that at least the second element exists. Type error. Count documents. Great. So I'm sort of building this up incrementally. I might know sort of what I want to do, and I want to do the distinct method, but this is sort of nice. I can sort of build, okay, does this make sense every step of the way? Yeah, it makes sense that there are 6. If I got an answer here where it was like 600, I'd be like, well, let's debug this step first. But then what I want to do here is I want to call distinct, and let's get the prizes.category, where this is the case. And again, it seems like, well, prizes.category is just true, chemistry, physics, and peace. Yeah, I think I have something in the notebook about, but we'll do that in the next chapter, sort of how to like get data out that's only what you need and not like the whole document in order to see things. So, among other things, I believe Linus Pauling got a Nobel in Peace as well as chemistry, so there are definitely a lot of opportunities for scientists to all contribute to peace. Okay. All right, let's do an exercise before we got like 5 minutes, that's good. Okay, distinct values given filters. Okay, all right. Don't want to alarm anyone, but the food's running a little late, so we might do an extra exercise. But it's definitely coming. Okay. All right. Born here, went there. In which countries have USA-born laureates had affiliations for their prizes? Here are a few options. I'd like you to construct this based on your knowledge of the schema. Feel free to, again, get a laureates or prizes document and find one to see which field is which. And I want to know in which countries have USA-born laureates had affiliations for their prizes, other countries. I'm going to put this up put up a poll for it. I'm going to give a hint. The hint is you're going to want to pass a sum key equals USA filter document to the dblaureates.distinct method, because this is a question about laureates, distinguished laureates. Okay, I think I'd like to go over this. So the DB laureates collection, we're talking about countries of affiliations of prizes. So if I look at one document here, I can see there's prizes, and within that, we're talking about affiliations and then country. So if I look at the dotted path to that, that would be prizes.affiliations.country. And what I'm interested in is all of those distinct values. Given that the born country is USA. And so we get the answer as number 1. So a little tricky, combining lots of different concepts. Dot notation, how dot notation behaves with nested arrays, using an aggregation method, how to build up a filter, combining that with aggregation. It's a small line, but there's a lot packed into it. Okay. Sean, how are we? Should we go for one more? Okay. We're going to do one more just to bake this in. I think this is good to bake this in. We're going to do this other exercise I have here, and we'll do this a little bit at a time. So I like baseball, so this is about triple plays. So prizes can be shared, even by more than 2 laureates. In fact, all prize categories but one, literature, have had prizes shared by 3 or more laureates. So the first thing we want to do, and I'll bring this out into a separate cell so we can evaluate it independently. Just copied and pasted. Save a filter document that, when passed to the method that returns distinct values of a field for the prizes collection, db.prizes.distinct, returns all prize categories shared by 3 or more laureates. That is, laureates.to must exist for such documents. So one thing I'm going to do right here is I am going to look at db.prizes. I'm going to find one, and I'm actually going to pass that dictionary and chain it to the .keys method so that I can just see all of the root level keys in that document, because I think category is somewhere there. So it's called category. Great. So that's sort of the number of distinct things I'm going to do. In terms of criteria, I want that laureates2 must exist. So this is a field. So the way I've captured this, the way Mongo works, right? This is sort of the X-array. This is sort of the field, and I want some condition on it. So I want to make sure it exists. So how do I do that? How do I stipulate that? Do people remember what's sort of the operator that I need for that? $sign exists. Fantastic. Thank you. And the value of it will be true. So that's our criteria. Now what I want to do up here is using octathorpes' the Python comment. So I want to save the set of distinct prize categories and documents satisfying the criteria. So I'm going to pass this criteria, and I want a distinct value that sets that. So I want the distinct categories. So what's the key value I put in right there? set.
I was somewhere else, like in the beginning.
Oh, set. Oh, yeah. No, very good. Very good. Yes. There's that gotcha from before with the assertion, so we want to make sure we kind of have a set. And distinct, we want the categories, and we know the root value is category. So this is good. So these are the triple play categories. And I'm actually going to go ahead and print these out. I'll type B here and do another thing, and want to see what these triple play categories are. We can see that Jupyter helpfully represents this as using curly braces because it's a set, it's not a list. And I guess this is what I've heard. I don't know if it's true or not, but I want to confirm that literature is the only category that is not a triple play category. So I guess what I'm doing here is I'm creating a set where I'm taking some output here, and I'm doing, it's one of the interesting things you can do in Python. You can do set arithmetic. So I'm taking this set and I'm subtracting from it this set. And I want that to equal some other set with just one value in it. So how do I, given this expression, confirm that literature is the only category not satisfying their criteria? So what would I put in here? Someone shout it out. Category. Great, so it sounds like I'm just going to get all of the distinct categories as a set. I'm going to subtract all the ones that are triple play, and I want that to equal what? A set containing what element? Literature. Great. So it didn't error, and so that means it's true. If I wanted to say literature with a capital L, that's false. That's just because of how our data is structured. It's using those exact strings. That's how we know it's working. Okay, so that's the end of Unit 5. I could get started with the first part of Unit 6, although do people know is lunch here? Patrick will check. We can keep going. So Unit 6 notes, that would be the unit to open on. Well, not lunch, the snack, right. I keep saying lunch. Okay. Were people confused, or were people just like, Donnie said lunch, but we know he means snacks? Okay. Well, I hope no one was confused. I wasn't confused. I just thought lunch is late. Okay. So now we're gonna go one level deeper, just dip our toes in a little bit. So now we're going to filter arrays using distinct values. And this just, you won't necessarily be working with this kind of stuff every day, but it helps to kind of go deep and be aware of these things, because there's a lot of nested structure that's really helpful for containing all the information of a document, and you can really slice and dice things quite well. How we represent our materials collection. It's on the materials project. We'll have a structure with lots of nested structure. We'll have arrays that represent the different elements that might represent different properties that are available for that material, different computational tasks. So there are lots of little arrays and nested things that you can really get at exactly what you want if you kind of understand how to compose things. So it takes some time, but it's quite valuable, and it allows us to structure our data very flexibly. And you could as well if you structure your databases this way. Okay, so array fields and equality. So this is part of the laureates collection document for John Bardeen. We are in, the Citrus Center. A lot of transistor work is happening here. People are very grateful for a lot of this work. I think it was great. So John Bardeen shared the Nobel in '56 for researches on the transistor effect, and also he's the B in BCS, superconductivity. So I'm going to go ahead and count the documents where the prize category is physics. So there are 209 laureates who have won prizes in physics. Maybe they've won prizes in other categories as well. There are 209 laureates. So I want you to imagine that there's this extra field in John Bardeen's document. There isn't this field. Laureates just have name and first name and surname, but imagine there's a nicknames field. And so John Bardeen's nicknames might be Johnny, J-Switch, JB, TC Johnny, Barty. And we might want to run a query like this. And I'm going to go over this query. So this isn't actually going to return anything. Well, so it returns a cursor, but it's going to be 0 because there's no nicknames field, right? But were this the case, you might have a few people, including John Bardeen, whose first name starts with a J, last name starts with a B. And what I want to bring to your attention is this filter matches in a sort of a very special way. You might think that you need to do something like nicknames is in, because it's well, that's not what I want to get at right away. So if nicknames is an array field, what does this sort of mean? Well, it's a shortcut notation that you just sort of need to commit to memory. It was a design decision. It makes things a little bit simpler, where this filter means either the nicknames field has this value JB, or if it happens to be an array field, then there is an element of that array that equals JB. And that's how you express that with Mongo notation. So it's something that once you learn, you sort of recognize, okay, that's a simple notation and that's what it means. So not only is it equality, but it's sort of that something's in a field. Okay. Now let's get to array fields and operators. So again, if I count these documents, prizes category physics, I get that. And I can also say, okay, prize category not equal to physics. What is this doing? I'm nesting in, right? I'm able to, even though prizes is an array, and this is category, it's as if this was kind of a virtual array. And there are several values, and if physics is one of them, then that's what you get. Similarly, we went over this before, the $in operator, just to remind you, this counts the documents where laureates have a prize category that's in physics, chemistry, or medicine. Now, one thing that's maybe a little counterintuitive and something to keep in mind about sort of what's going on under the hood, this document will count laureates who have a prize in physics. This query will count Marie Curie, for example, who has a prize in physics and in chemistry, because she is a laureate that has a prize category that is not equal to physics. There are ways around that, but it's another thing to kind of keep in mind, sort of a trade-off about the succinctness of the notation. Similar thing here. So what is that thing that I want to get at? It's called element match. And it's how you can match specific subdocuments in an array where all of the fields meet some certain condition. So here's what I mean. What's happening here? Here I'm counting the documents of laureates where there is a prize that is exactly this. It has a category of physics and a share of 1. No such prize exists because there's more going on in a prize. Prize also has an affiliation, right? I'm not sure exactly how intuitive this is, but I wanted to point out this wrinkle to you. That this is an equality thing. And just like there are other operators to sort of wrap around, like what do we mean by this thing in this context, there's something that will come up upon that means, okay, actually I just mean that this should be contained in that thing. It works at the outer level, but not at this inner level. When I say something like this, these things are an and statement. They run independently. So this is counting a document where apparently there are a bunch of them where there is a prize with a category of physics and there is a prize with a share of 1, not necessarily the physics prize. So again, have to be a little careful. How do you get around that? Through this through this thing. So there's actually one document where it sort of fits that but doesn't fit this. And what you're saying is, I want there to be a prize such that for this element, I want you to give me this match, that its category is physics and its share is 1. There really is no substitute for finding out like what you want to do and formulating it and going to the Mongo documentation and looking about how the various operators work and how they'll work to your advantage. But what this afternoon is for, especially this kind of advanced stuff, is giving you a taste of sort of that there could be little gotchas, and it pays to interactively kind of debug and make sure you know what's happening. Okay. Again, you can keep composing, and some Mongo queries can be very extensive, but again, because it's just a simple data structure, you can compose things. So you can say something like, well, I just want to find laureates who won a solo physics prize before 1945. Because maybe I'm interested in the rise of collaboration in physics award recognition after World War II. So this is one query I might want to do. How many laureates won an unshared prize in physics before 1945? Okay, enough notes. Let's try and solidify a couple of these concepts. So I'm going to Unit 6 exercises. And actually, this is exactly what I want you to work on. So given the format of the last, feel free to copy paste. What is the approximate ratio of the number of laureates who won an unshared prize in physics after World War II to the number of laureates who won a shared prize in physics after World War II? This will be up on here.
Category physics, prize.share 1, and then there's 47 for the other one where you use the LM match. What's the one document that you're not getting? Like, why is it? How is it different?
Great. That's a great question. So the question is, essentially, what's going on here? This is 48 and this is 47. Why? And maybe we can get some insight by seeing like what that one document is. So what I believe is if I find a document that has first name, well, let's see. I want a laureate where they have a category of physics and the share is not equal to 1 for that prize. And I also want a laureate for whom they have a prize that is unshared. So this is Marie Curie, and what's happening here? Marie Curie has won 2 prizes. The first prize that she won was the 1903 prize in physics, which was shared for radiation phenomena. She subsequently won a prize in 1911 in chemistry, which was unshared. So that's the difference here. That's the one document that falls out, where yes, one of her prizes was in physics, and yes, one of her prizes were unshared. But we're interested in specifically prizes that were awarded in physics without anyone else awarded that. So that's the difference there. Very rare in this data set, but often we're interested in the outliers. So I hope I've also hinted at this being unshared, where shared being essentially wrapping this value with the $NE not equal to operator. That would be the key to answering this question. Okay, great. We've gotten a lot of responses. what I'm going to do is I'm going to copy this block here. I'm going to paste it right down here. And so this is after World War II, so $GTE, share 1, so this I'll call unshared. And I'll also have one that I call shared, where the share value is not equal to 1. And then I'm interested in the ratio of shared to unshared, or maybe the other one, unshared to shared. Yeah, that's pretty incredible. 13%. So most Nobel Prizes, a very high proportion after World War II, have been awarded to teams. Big science had a big boost with Lawrence, who helped found the lab with the cyclotron. An era of big science ushered in lots of periodic table elements, and so teamwork is a big thing in science. That's been recognized. And it is time for snacks. I will put up a poll where I ask how this went, but feel free to do that, after you eat something. So I'll put that up, and we'll go and we'll come back here like 3:20. Give ourselves 15 minutes. Thank you. So there's a little more. There's another exercise to get a little more practice with LMMatch and things like that. But we are going to go on to Unit 7. So let's go to the notes there. I'm going to open up my copy of the notes. So that I can kind of just type things in. And you can choose your own adventure. Okay. So what this is going to be about is finding things that are not exactly equal or not exactly, in a set or not. We're sort of not comparing equal values, but things that are similar to. And we're going to use, if you haven't used it, then this will be your little introduction to it. This sort of syntax, this mini language called regular expressions that enable you to tell if some value, some string value, is similar in some specific way to another string value. So here's something simple. We might say, let's find a laureate where the first name is equal to Marie. That gives us one document. There could be others. I don't think there are others, but it finds one, Marie Curie. Okay, so let's just look at Marie's document here. We see that she was born in this country, and what is this? Okay, it's not Poland. I get, technically she was born in the Russian Empire, now Poland. Okay, so if we want to find laureates who were born in Poland, we can't exactly search for born country Poland. I'll just go ahead and count these. Well, of course we can. We do find a number of them. But this actually won't count Marie. But what we can do, and I'll use the distinct method to give us all of the variety that we have here, is I'll say db.laureates.distinct, give me the distinct born country values such that, I'm going to break a line here. So my second argument is going to be, well, what do I want? I want a filter for born country where, okay, I'm going to need to do something here. So I think I'm going to need to use an operator. That's what we do with Mongo a lot. And here's the same, $regex. This is specifying a regular expression. This means I want something that's not equal to, but is like something. Now what I'll do here is I'll simply say Poland. Because I'm wrapping it with the regex operator, it treats it as a regular expression. And in this case, it's simply searching for Poland appearing as a substring within that field. So there are several laureates that, where their born country field value is Russian Empire, now Poland, Prussia, now Poland, Free City of Danzig, now Poland, Poland, now Ukraine, can go either way. This is just how the Nobel API decided to encode this stuff. Now, we know with MongoDB and hierarchical structure, we could maybe do a little better. Maybe we'd structure this differently. Maybe we'd say born country be a dictionary and, say like, current, like the name, and then like, previous, and maybe have an array of previous values, whatever we want to do. But this is how it's encoded here. However, one thing to note is if we have this be lowercase p, nothing's going to come up because it's very exact, right? But you can actually pass flags to regular expression operators, people know. You can say things like, okay, I want this to be case insensitive. That's one little trick we can do. And just as a sanity check to make sure there are no weird things where sometimes Poland is capitalized, sometimes it's not, just so we can sort of proceed with things. I'm going to label this result case sensitive. I'm going to create another block called case insensitive. And in this case, the option here happens to be there's this $options key, and I can give it to the string little I. And this is something that Mongo provides. It's used in conjunction with regular expressions. We won't go a lot into regular expressions. We'll just do very simple stuff, but there are lots of options. And so this would be case insensitive. And I guess what I want to confirm here is I want to assert that, the set of these results is equal to the set of these results. And it's true, so I don't need to worry about case insensitivity anymore. So that's nice. And again, I'm trying to model, the idea, with Python especially, it's nice as a dynamic language, you can just give yourself these quick assertions and test yourself along the way, which is no substitute for a comprehensive test suite when you're writing a larger program, but this kind of stuff is nice. There's one other last little way of doing this. There are a couple of ways of doing it that I want to emphasize that are possible. This is something that's Mongo native, but Python also has its own regular expression library. And just to show quickly how that's done, we won't be using it too much. But just so you know, there's, in the standard library, we don't have to install anything else. There's this RE regular expressions module. And what we can do is we can say db laureates.distinct born country, and our filter here with Mongo, we sort of express this object as a simple data structure. It's not some fancy Python object, it's just a dictionary. How do we know it's a regular expression object? Well, because it has a key called $regex. And that's how we know it's that. But with Python, you can sort of have this non-JSON, non-base data object called a regular expression. And I can sort of compile this thing, Poland, and I can, Python has its own way of ignoring case. And, PyMongo says, okay, because you're in Python, you can use regular expressions as you want. So that's something that you can do. And there are other facilities like that, which we won't get into, like for dates and times. You can use native Python date times, and if you look at what's happening in a Mongo database, you'll see it's obviously not a datetime object, it's a plain object. But it'll have these little $sign things that say, okay, this is like, it might be like $date, and it might have like a representation. So it does these things so it represents it as very simple data that you can transport over the web, and then when you deserialize it, when you take it into your Python and programs, you can have fully featured objects. The last thing is, when you install PyMongo, there's also this bson package, which is binary JSON. It's Mongo's thing. It sort of encodes how it encodes dates and sort of things like that. And so, honestly, I'd recommend if you do a lot with regular expressions and you want to use native objects, I would look to the bson library for things like this, rather than use Python regular expressions, just because there are a few subtle differences between Python regular expressions and what MongoDB uses, which is sort of the earlier Perl-compatible regular expression format. And so how you do that with this, and we'll sort of use this for subsequent exercises, we'll sort of assume this is imported, so we don't have to write so much with the $regex, but you know that it's there, is we do something like DB laureates distinct, born country. The construction is very similar. And we simply construct this regex object with the value Poland in this case. Missing a capital C. Great. Thank you, John. Okay, I'm going to copy this, and I'm going to go down to this section and paste it, because now we're going to get into how we can use a bit of regular expression notation to solve our dilemma here. Or rather, the dilemma that I'm going to present, the challenge that I'm going to present, which is that it'd be nice to separate these, to partition this set into members that have now Poland as a parenthesis, ones that are just Poland, and ones that are Poland and now another thing. So I'm going to use a couple of just quick techniques to illustrate what you can do here. So one of the things is there's this caret character. So that little key that's hopefully above the 6 on your keyboards. And what this character does is it says, hey, regular expression parser, I want this, where I'm standing, this caret character to be the beginning. So this is the beginning, which means the first character of the string has to be capital P. So in Python, it's sort of like string.begins with, right? But this is using the regular expression language. So that's how we get that. Let me go up here and do this again, just so that we see all of our different options that we want. Okay, so the other thing that we want is something that has, Poland and now something else. Well, okay, let's copy this. And we can just say Poland now, and that should be fine. But it actually fails, and it fails because it reveals something a little more powerful with regular expressions, which is that there are certain special characters, just like the caret. You might say, what if I want a string that actually starts with a caret? And the way you do that is through a backslash, so you'll escape. And so what this is saying, instead of starting a parentheses where, later what you can do is you can group something and say, like, whatever this captures, I want to then use that in something else. It says, no, I really just want an open paren. And so now we get that. Oh, this is interesting. We got this thing here, which didn't start with Poland. So actually, what I really want here is a caret, right? Now, the last thing I want to introduce is sort of the ends with idea. And if we want something where, okay, it's it ends with now Poland, I can do let's see, now Poland, and this is also a special character, as I mentioned, so I'll want to escape it. And the way to get this last little bit and say I want this at the end of this string is a $sign. That's also that special character that says I want this to be at the end of the string. Parentheses too much. Oh boy.
No, you just have an extra. Now Poland, just take off the correct.
Now Poland.
There you go.
There we go. One too many. And this closes the regex, and this closes that. Okay, great. So we've learned three things for regular expressions. We've learned that just having the string on its own means sort of somewhere in there. We can have a caret to quickly indicate this needs to be anchored at the beginning. The $sign means anchored at the end. And if you have a string that you want to see if it has a caret or has a $sign or has another special character that you discover you haven't learned about yet, but special, like open and close paren, you can use a slash to escape it. Slash is also a special character, right? So you also need to escape that. Okay, let's get on to some exercises. This is a little different. Right, Unit 7 exercises. Okay, harking back to our nicknames thing with John Bardeen, JB. There are two laureates with Berkeley affiliations that have the initials GS, Glenn Seaborg and George Smoot. I'd like you to find how many laureates in total have a first name beginning with G and a surname beginning with S. here's the hint. You're going to evaluate this expression, and you're going to fill in these blanks appropriately. And here are the options. Make sure you evaluate this block at the top so you definitely have a connection to your database and you have regex imported. Okay, I'm getting a lot of answers for being 9. Let's check this out. Okay, use some indentation here. So I want the first name beginning with a G, capital G. So if I want it beginning with it, I want to use this anchor character to say, okay, first name starts with G, and the surname starts with S. So I get 9. Great. Okay, there's another exercise. This is a nice one. We won't have time for it, but you know, the motivation is a big string, so you kind of want to see maybe which prizes were related to certain topics, like transistor or that sort of thing. Regex is a great operator for that. We won't be doing that. I want to move on. Okay. We're going to move on to some bigger ideas that you might not encounter day to day and be in the weeds for. You know, a lot of this stuff tomorrow and Friday when you're querying the materials project database is mostly about finding things and constructing queries for advanced stuff. But this is going to be helpful. When you have a lot of data, you don't necessarily want all of the information, the full documents. So this is going to be about getting only what you need, and fast. Fast because you're only getting a little bit, but also we'll talk about sorting. So Mongo has this idea of projection. It's the same as selecting fields in SQL. So projecting, you know, in lots of math topics are sort of reducing data to fewer dimensions, projecting onto an axis. You can also think of it as asking certain data to speak up, you know, project. Here are some examples of you know, projections of maps, but that's not exactly what projection is in MongoDB, but it's still sort of, you have this big thing. In this case, it's a globe, and you kind of want to just focus on certain aspects of it. And in MongoDB, you want to sort of project out from a document only things that are interesting to you. So here's what I mean by projection. We've encountered this with distinct, where there's a second argument, but even with find and find one, there's another argument. This argument is called filter, this first argument. And the second argument is called projection. We're not referring to it by name, but of course we can, as was demonstrated before. And what we do here, very, very MongoDB-like, how do we express our projection? Well, we can express it as a document. There is a shortcut, which is if you're not specifying that any field should be excluded, then you can just have it be a list. And I think a lot of people just do that. That's very convenient. Here, I'm specifically saying I want you to project out the part of this document that has to do with prize affiliations. So, you know, that's going to be 1 or true. And I don't want you to project out the underscore ID, which gets projected out by default, because it's a way of unambiguously identifying an object. So what I'm going to do here is I'm going to take that line, this cursor, which I can draw things from. And I'm going to say, pass it to this list constructor. So it's actually just going to pull all the documents. So now that it's a list of dictionaries. And I'm just going to slice. I'm just going to take the first 3 documents. So that's what I'm doing in this line. So we can see that this projection has structure. Rather than trying to give single values and replicate that you want some field called prizes.affiliations, it's saying, okay, you want that part of the document. So I'm just going to return that part. So this is a list of documents where we're projecting out, these are the subdocuments. So one of the documents, we're projecting out the prizes key, but not everything in there, not the prize category or year, just for each prize, the affiliations, and all of the affiliations, affiliation name, city, country. So that's what projection means. For simple fields that aren't nested, it's very simple, but otherwise, what's nice is MongoDB will retain the structure of the documents for you. What about missing fields? So here I'm using this other form where I am just going to express the projection as a list. Fine, give me the underscore ID. And I'm going to get a couple of documents which are organizations, and I'm going to get their born country and first name. I'm also going to quickly say we're not going to go over this because it's not terribly interesting, but it can be important. You certainly don't have to fetch all of the documents of something if you're only interested in 2 of them. You can pass another argument to a cursor saying, just limit this to 2 documents, and I won't pass everything over the server. But we're not going to deal with that complexity right now, and also just reinforce the idea that this is an iterator and you pass it to a list and are slicing. So this is a little bit more pedantic than practical. So it's passing a couple of objects, and so this returns a list of objects, and here's the first one with this first name, and this one has a first name, but there's no born country. How MongoDB handles projection where there's nothing there is it doesn't give you an error, because Mongo is a database that allows flexible schema. So yeah, maybe some documents don't contain that. So it's not going to say error, born country invalid field for this thing. It just won't return that at all. It won't try to do something that it expects you to know something about, like return none. It's just not going to return it, so you know it's not there. You can do this with anything. I can want to know the favorite ice cream colors. Or flavors. And it's just not going to return that. It'll return the underscore IDs for all these laureates. So again, we're not going to get into aggregation. Here we're actually building up a cursor where we're going through all laureate documents without any filter. And because we're going to say this is a large collection, we're really only interested in a little bit of the data. We don't need to pull it all from disk or anything. So we're just going to get prizes. So we're just going to project out prizes. And we'll just count the number of prizes by keeping this counter and adding the length of this array. And we can do that either of these ways. In the real world, you'd probably like to actually do this on the server with an aggregation command. But in cases where you can't, because arbitrary aggregation can be really expensive unless everything's indexed, actually, the materials project, we don't allow you to do arbitrary aggregation on our server. So we ask that you sort of query for what you need, even if it's everything. and just sort of project out what you need to do your analysis and cache it offline. So this sort of technique is useful for that. But if you have your own Mongo database, you can do whatever you want. Okay. Okay, we're going to do a little projection exercise. You want to examine the laureates of the 1903 prize in physics and how they split the prize. Here's a query without projection. I can do that. Okay, so give me a cursor, laureates.find prizes, such that there is one document, one element in the prizes array that has both category physics and year 1903. Which projection, or projections, it could be multiple of them, will fetch the laureates' full names and prize share info, because that's what you're interested in. And I'll put this poll up. Okay, let's go ahead and test these out. So I'm setting up a little block where I have a projection, and I can at first specify that there's no projection in this case, and I sort of get all this stuff out. So I want prize share info. So if I do this, get first name, surname, and here are my prize shares. Great, got it. So one works. If I do this, I also get prize share info. And what's nice about this is I get even less data. I don't get all this other data that I don't need. This last one's maybe a little extreme, but it's nice. We get exactly what we need. So the answer is 4, all of the above. Now, in certain cases, this is actually going to connect with what we're going to discuss next, which is indexes, because in certain cases, if you have certain queries, if you're managing a large database that you want to be very performant, that people do a lot, you can actually have them be contained entirely by the index and covered by queries. So if you have these very efficient projections, in many cases leave out the underscore ID, you can have very efficient performance. Something to just be aware of. Okay. I'm not going to go over this exercise, but I just want to bring up, there are other exercises, and here's one where we kind of explore the idea of actually taking that share field and making it a little more solid by importing like the fractions module from Python and making sure things are actually valid. But what we'll do now, we have 2 more units, and on the agenda it mentioned that we were going to be targeting ending at 4, but then a bit of sort of cleanup, run over by 4:30. So that's what I'm going to intend for. I'm going to intend to get these 2 units and communicate what I want about them for about 15 minutes each, and we'll target to be done at 4:30. So the couple of topics that I wanted to communicate are sorting, very important, and indexes in MongoDB. So I might just run through that we can conceptually get these and execute, and the main interactivity will be in the exercises where you really have to make sure that you know what happened. Okay, so certainly we can sort post query with Python. In this case, I do a query for prizes with a category of physics, and I just project out the year. I get a bunch of documents, and what I'm doing here is I'm just sort of printing out the years. I am doing a list comprehension where for every document in my documents, I'm just grabbing out the value of the year key. If we look real quickly, one of the documents, this is what the document looks like. It's a dictionary, it has an underscore ID field and a year field, because that's all we're projecting out. So in this case, I just take the year, I get that whole list, and I print out the first 5, and I get that. They happen to be reverse sorted, but that's not guaranteed. If I wanted to do something in Python, I could use the sorted function, which, given a list and some key, which is a function, given a value to give it some kind of value. This is a little maybe obtuse here, but what item getter year is, it produces a function. Maybe I'll just do a quick function here so people sort of know. Get year of a document, return document year. And so my key here is this get year function. Because these documents are very complicated things, they're dictionaries, if it was a list of integers, then sorted would know how to sort those, right? I'll just compare these two integers, but how do I compare these two dictionaries? And so this key is a function where you give it the dictionary, and it says, well, here's the value that you should use to compare these things. And so in this case, I'll get things in ascending order, because that's the default for sorted. If you pass it this keyword argument reverse true, then you get that. I happen to be using this function in the standard library. I think you saw in the other tutorial, operator also has things like add and subtract. This is a simple function where you give it a key, and it essentially means what I just wrote up there. There's no harm in writing your own little function to do it, but just know that there are lots of things that might be common. There's a good chance that Python standard library has them, or another well-supported third-party library. You don't necessarily need to reinvent the wheel. If it seems like a wheel, it might be. So now there's that sorting, where you get all the documents, but you can also sort in query with MongoDB. How you do this, we have this first argument, which is the filter, and the second one is always the projection. I don't know if sort is the third argument. I forget. I don't need to worry about it, because I can just give a keyword to Python. So whatever position it's in, I sort of just say, okay, I want sort to be this. And so what does this mean? And most of all, why is it not in the form of a document? MongoDB likes documents. Why is it a tuple? We'll get into that in a minute. But essentially what you're saying is you want sort to be, okay, it looks like it's a list, and that'll make sense in a little bit below, but essentially we sort of want to sort by year, and this indicates the direction. So 1 is going up, ascending direction. And the counterpart to that would be in the descending direction. And so this is how you have this cursor, and you sort of only yield what you need. Now, this sort of yields them all, and then does the first 5. I'll just show you real quick because it seems fine. I can also pass, say, limit equals 5 to this. And then I don't need this thing at all right down here. Because I'm telling Mongo, just give me the first 5. So briefly, that's limit. Now, why is this a list? Well, one thing we can do is we can sort first by one thing, and then for each key in that first thing, we can sort by another thing. So what we're going to do here is we're going to have a cursor, and we're going to search for all prizes where the year is greater than 1966 and less than 1970, the string value. But because of the way sorting with strings work, this will be all that have the string value 1967, the string value 1968, and the string value 1969. We're projecting out the category and year. That's all we need. And we're going to sort first by year in ascending order, and then for each year. So we might have multiple prizes from the year 1967. We're going to sort those documents by category. So economics is going to come before physics for 1967. And I'm using a for loop here, and I'm just going to sort of do this thing. I'm doing this shortcut where instead of saying year equals doc year, category equals doc category, this is like any function. They're keyword arguments, right? Year equals this, category equals that. I can actually take one of these document values and use this double star to deconstruct that and say, like, I want you to pass me as keyword arguments. And so that's what it's doing here. One more. And this format is sort of taking the year thing and doing that. Yeah. And so you can see it's sort of sorted first by year, and then within each year, sorted in decreasing order by category. I'll leave that up. Okay, so here it answers the little question, well, like, why are these tuples? Like, I get why it's a list now, because I want to do this first and then second, but why tuples? Why a list of tuples? And actually, in the MongoDB shell, which uses JavaScript, because it's based on JavaScript notation, you'll pass the sort argument as this object, year 1, category -1. And that's because in JavaScript, objects retain the keyword as entered. In Python less than 3.7, you could enter in a dictionary, year 1, category 1, and you don't know what order it's going to come out. So that's why in Mongo you have this, okay, we can't exactly do key value, and that's the order. We need it to be a list. So how are we going to represent that? A list where the first element is, okay, I have 2 things, and I'll just have the first thing be the key and the second thing be the 1. Interestingly, in Python 3.7, dictionaries are ordered, and that's what you're using on this notebook. So this is no longer a problem, but you want to maintain backwards compatibility. So that's sort of a little thing of like, well, why is that a little bit different? That's why it is in Python. Okay. Let's do an exercise. This block here prints out the first 5 projections here's the full list, and for doc and docs, first five projections of a sorted query. And here are the first 5 outputs. What sort argument fills the blank? So we're trying to find laureates born 1900 or after, who won a prize in a year after 1954. And we want out that born year and the prizes dot year projection and no ID. And we want to sort them, get the first 5. I'll put that up. Okay, we've got a bunch of answers. Let's try it out. So one thing you notice here is this sort of doesn't overshadow this. This is a variable that I'm creating with the name sort, and this is just a stand-in for the string value that's going to be sent to this function. So it's maybe a little confusing syntactically. I just wanted to point that out. Okay, that looks good. Let me see this other one. Oh. Not allowed. So even though it could technically work in Python 3.7, the PyMongo driver says, no, I expect a list of tuples. So that's one thing to note. So yeah, this first one is right. Well, I wonder if this actually produces the right answer. None. If there's no sorting, does it happen to work? No. Okay. So what's going on here? Again, it's subtle and it kind of deals with there being lists of things. This document here technically does have a prize year that's 1962, so maybe it shouldn't be before 1955. But in fact, this document does satisfy the query that there is a prize with a year that is 1954, and so it sort of sorts within there. And for each year, we sort of have this date going down, 1916, 15, 01, and 13, 11 for 1955. Okay, we won't go over this, but here's a way of using MongoDB and Python to sort together. Yeah. There's also a little bit of sort of simulating aggregation by using group by functionality in Python. So there's some good stuff. Okay, but let's go on to the last lesson on indexing. Okay. What are indexes? Here I have one of my old friends, Shackelford, Intro to Material Science. An index in MongoDB is like a book's index, right? Let's say I grab a textbook on material science. I want information on eutectic temperatures. I could flip through the book, right? Look at every page. I could also try narrowing down to a chapter by looking at the table of contents and sort of see sort of where I am. Instead, I go to the index of a book. I see an alphabetical ordering of terms with page numbers for each. I find eutectic temperature, which directs me to page 314, and voila, I'm there. So that's pretty handy for a book, and it's analogously handy for a database. With MongoDB, imagine each collection is a book, each document as a page or section, and each field as a type of content. Imagine an ordered index for temperatures. This means you can find all pages that list temperatures in a range of interest. It's hard to do with an actual book, right? But MongoDB structures documents with fields. Thus, you can index fields using the values of those fields. So when to use indexes? Well, first, when you expect to get only one or a few documents back, that's when they're very useful with high specificity. If you're if most of your documents have, if you're doing a bunch of calculations and you decide to represent the results as being invalid or valid, and you actually only put all of your documents that are valid in a collection, so all of them have valid equals true, you probably don't want an index on valid because it's not really specific. An index like first name is really specific, because of a collection of 900, maybe only a few have the first name. So then you can bypass a large part of the collection right away. Is it great to have an index on categories? I don't know. There are only a few categories, but if you're doing multifaceted search and really drilling down, you already sort of get a jump of an integral factor. You sort of divide your set by about 8. That's still pretty good. So I would, consider that. Also with large documents, it can be helpful because if you have indexes on a couple of fields, then you can just sort of search for those fields without having to open the entire document and find that field and do it. You sort of have it in the index. And finally, it's just good for very large collections because oftentimes the index is so small that it can be kept entirely in memory. The index of the back of a book might be a small fraction of the number of pages of the entire book. And so you can just sort of have that index and search the index very efficiently. However, if you're considering this for your own collections, it's important to gauge performance before indexing. And this is also a nice opportunity just to introduce some Jupyter Notebook magic for Atomate, which is the same as something that comes in with Python, where you can time an expression. So here, I'm just going to sort of find all documents with the year 1901 and collect them all into a list, and I'm going to %% time it. And what's nice about this is it's going to run it several times and find some statistics on it. If you just run it once and time it, it could be that someone was sending you a text message at the time, or something else was going on your computer, and so it ruined the timing. This sort of does a lot of stuff, so that makes sure that you get a little bit better of an estimate. So we see it's about 0.7 of a millisecond on my system. And this other thing, I'm going to go ahead and find all the prizes and sort them by year. So it takes a lot longer. It takes about 5 milliseconds on my system. Now we're going to see what happens when we add a single field index. So an index model is a list of field direction pairs, just like for sorting. And what I'm going to do, and by default it'll just be sorting. The direction can matter if you have compound indexes on multiple fields. So you something is sorted in one direction, you want the other thing to be sorted in the other direction. A little nuance to know, but that's why the syntax is like that. But once I create this index, and then I time the same query as above, before it was 710 microseconds. Now it's a little less, right? This other one was 5 milliseconds, a little less, slightly 5.7, 5.04. So not that impressive, right? Wrong. This is very impressive because there's no reason why this should take much longer at all. As I mentioned, this collection, it's like 1,000 documents. They're all pretty small. It fits in a quarter megabyte. It's all in memory. We're not paging to disk. We're not, going over a network. So the fact that there's like a little bit of speed up on this little thing means, it's going to be a lot more significant for things that actually matter. I'm going to go ahead and drop this index on the collection, just so that we can have apples to apples on other stuff. So here's where things get interesting. You can have an index that so-called covers a query with projection. So we might have something that we do a lot, or for some reason, it's a toy example, but we might want to find out all of the years that the economics prize was awarded. It wasn't all years. So we find, okay, about 800 microseconds. Now I'm going to create this index where for every document, we sort of have this index of categories. So each category points to all of the IDs that it references, the page numbers, if you will. And in each category, not only does it point to the page number, but it also has a separate index on all of the years and sorted by that. So that's all contained in the index. So you never have to hit the database if you're just interested in finding by a certain category using this index, and this is already contained in the index, and you're not using anything else. So again, I don't expect this to be too significant because it's just in memory, but it's actually like a higher percentage than before, I'd say. Similarly, you could cover something with projection and sorting. So I might have this thing where I, again, return the years, but I also sort it by increasing year. So I'm doing a little more work on the server. I'm not just projecting, I'm sorting. This is going to take about this long. But then I create this index again, and now time that. And it's great, and it just hits the index because for each category, because of the way we structure the compound index, each category already has a sorted list of years that are associated with it. And you can also go into those documents. It points to the ID of the documents. But if this is all you're interested in, it's incredibly powerful. Okay. The last thing I want to mention, in case you're managing Mongo databases or want to sort of see what's going under the hood, Mongo is pretty introspective. So you can ask your collection about what's going on. So for example, I want to ask laureates about index information. So there's always an index on the underscore ID field. It's very highly specific, right? If you have the ID of a document, you'd go right to it. Of course, you can add indexes, which we did and we dropped. One thing I can do here, I can take this query, first name Marie, project out the born country, and I want to instead of taking this cursor and acting on it as an iterator and collecting it by list, I just want to explain what's going on. What's Mongo going to do? And here's where you can really find a lot about how Mongo works under the hood if you're so interested. So what's happening here, okay, here's the winning plan. So what's happening is there's a projection stage where it's projecting out this. And this is the transform. And the input to that is a collection scan. So it's scanning the entire collection by this filter and then projecting out this. That's what it's doing. A couple other notable things. It's going to need to examine 934 documents, all the documents. It needs to scan the whole thing. So just so you know, what it's going to do. If you're ever managing a database and you're wondering why is this query taking so long, I think I have an index on it. You might not. So you might want to explain the query and see what's actually happening. So now what I want to do is I want to create an index on first name and born country, which I think will cover this. explain. And what I see here is, here's the winning plan, projection, and here's the stage. It's an index scan. I'm using this key pattern, the index name, and there are lots of interesting things. One interesting thing is, it examines 0 documents. It never hits the collection. You just want the country of birth of Marie's. I'll just give you that real quick. You just go to the index, you get your answer in the back of the book. You don't even have to hit the book. You won't be dealing with indexes much, well, at all, for the rest of the workshop on Mongo databases anyway. But I thought it would be really helpful to round it out with that. So let's do one exercise on indexes. Okay. In the year 3030, everybody wants to be a Nobel laureate. Over the last thousand years, many new categories have been added. You serve a MongoDB prizes collection with the same schema as we've seen. Many people theorize that they have a better chance in high share categories. They are hitting your server with similar long-running queries. It's time to cover those queries with an index. Otherwise, your server is going to go down. Which of the following indexes is best suited to speed up this operation that everyone seems to be doing? They want to find all of the distinct categories such that laureate share is greater than 3. So here are the index specs. So which of the following indexes is best suited to speed up that operation? I'm going to put the poll up. Let's go over this. Okay, so what's happening? We looked over our explain. So what will happen is there might be a couple of stages. There's going to be a projection stage, but that's, there's first like an input stage that has to filter. So it's tricky here because a lot of the stuff we've been seeing in terms of collection.find, the order of the arguments is switched, where we kind of have the query first, and then we have the projection. But here with distinct, the filter, the query, is actually the second argument. And what we kind of aggregate, and thus what we need to project out, is the first argument. So in order to make this really fast, we first want to get the stuff we need really quick. So that's laureates.share. So I would index on that first. And then after that, we can get the category out. Now, I heard a question, do you actually get that much speed up, or is it worth storing all the categories in the index as well? That I don't know. So I will accept 2 as a potential answer as well. But what I was thinking is that, just to cover everything and to not hit the collection at all, assuming that the index isn't too large in memory, you'd also want a secondary index on category. So for everything in that laureate share greater than 3, it's going through each of those values of the index, each of those blocks of laureate share 4, laureate share 5, whatever. For each of those, it already has all the categories attached to them. It can then just get that from the index and aggregate them and return the distinct ones. So I would argue for 3 as being the thing that gets it all in the index, but who knows? Okay, there are other nice things, exercises. Encourage you to explore in your own time. They're certainly not going to be needed for tomorrow, so don't feel like you need to do them tonight, or do them on your own time. And yeah, that's about it. I want to be sure to put up a poll for how this afternoon went, the last part of it. So I'm going to take this poll and duplicate it real quick. I'm going to edit it. Make sure it's Mongo Primer 2. Second half. Save that. And I'll put that up. So this poll is now up. That asks you about, what went well and not so well for today. And make sure to bring your badges tomorrow. And also, feel free to stick around a little bit if you have any lingering questions. We're sort of just finishing up and we can tell you anything about tomorrow. Otherwise, see you here tomorrow. Thank you for priming yourselves. It's going to be a fun workshop. Great. Thank you.